So paper 6, again, the last question seemed like chemistry, planning experiment. This question is having like sometimes 6, sometimes 7 marks. So this is from session 2020 papers. A student investigate a wind turbine, which is an electrical generator driven by a propeller blade. So here, like this is a wind turbine, as I mentioned here, which is an electrical generator is there, and it is propelled by uh, basically what will happen, the electric fan will blow the air. So when the air will move, it will collide with a propeller blade. As a result, these propeller blade experience the force and start to rotate. And there is a coil inside. There's a coil inside. That coil will also rotate with the blade. And due to the rotation of the coil, there is a change in the magnetic field. And whenever there is a change in magnetic field, there is always induced EMF. So there will be induced EMF, or EMF will be induced or produced. We have to plan an experiment which will which will enable him to investigate how the current in the resistor connected across the terminal of a turbine vary with the speed of airflow. Like what is the effect of changing the speed of airflow on the current produced in the resistor that student want to investigate. The apparatus available, the model of a turbine is shown in figure that is given. Electric fan is there for providing a moving air to turn the turbine, and a device to measure the air speed that is also given, like what is the value of a speed, meter per second speed is there. So in your plan, you should include a list of additional apparatus. So a student is investigating how the current produced changes with the speed of an air or a moving air. So what additional apparatus a student required for this? Because student want to measure the current produced due to the movement of the air. So if we want to measure the current, what apparatus we need? We need an ammeter. So the additional apparatus which student should have here, that should be an ammeter. Then complete the wind turbine circuit diagram. So we have to complete this wind turbine circuit diagram. We have a resistor here. Then we should have an ammeter to measure the current. Then the state key variable that must be kept constant. So we are finding the effect of wind speed or speed of the air on the current produced due to this turbine. We have to keep all the other parameter constant. So what parameter or other key variables which we can keep constant here? So the distance, number one, like example, the distance should be constant as well. The distance between the fan and the turbine should be constant. What else? Because we have to change or vary the speed. So the speed, we cannot keep it constant. We have to vary the speed and find how much current is produced. The height where the fan is placed near the turbine. So the height of the fan should be kept constant as well. So these are the two variables for a fair comparison. The height of the fan above the bench and the distance between the fan and the turbine should be same. Only thing which what we'll do, we'll change the speed of the fan and we'll find how it affects the current. Then explain briefly how to carry out experiment, include how the speed of airflow is to be changed. So how we carry out the experiment, the procedure.
Mister, every point have mark.
Yeah, every point is having mark.
Yes.
Like example, when you draw the circuit diagram, if you draw the circuit diagram correctly, that will give you 1 mark. When you mention about m meter, the second point we mention about m meter will get the second mark. When you mention about distance and height, the variable, key variable, you will get the third mark. Then the procedure, we have to mention a procedure how we carry out this experiment. So what we will do, we'll switch on the fan at certain speed and we'll measure the current by using an ammeter. Then we'll change because we are finding the effect of the air speed on the current produced. So first what we will do, we will keep measure distance and height, or measure distance between the turbine, the wind turbine, and the electric fan, because we want to keep them constant. Then we will switch on the fan. And fan, we can change the speed of the fan by changing the level. So we'll switch on the fan at level 1 and measure the current. Then we will repeat the experiment by changing the level of the fan. And measure current for each speed. Then can you identify the dependent and independent variable? Here, two quantities are there. One is the speed of the fan speed. Another one is a current. When I change the speed of the fan, the current changes. So it means the speed, or when I change the wind speed, the current changes. So current depends on the wind speed. So current is a dependent variable. The electric current or current is a dependent. And the speed of the fan or the air speed is the independent. So when you are measuring two quantities, it is better you mention, even they did not ask for it, they did not ask which is dependent and which one is independent. But whenever you are writing the procedure, you should mention independent and dependent variables as well. So current produced depends on what is the wind speed. So current depends on this wind speed. So current is a dependent quantity, where wind speed, air, we are only changing. So that is independent. Then the last part, explain how to use a reading to reach a conclusion. So the best way to reach a conclusion is always plotting a graph. This is the best way. Like we can have different values. We can plot a graph between the current and fan speed. Or you can also draw or make a table where two columns. One is including the fan's air speed, another one is the current. So here you can mention, plot a graph between air speed and current. But when you mention plot a graph between the quantities, you should mention which axis you are plotting a graph. Normally in physics, on x-axis we have independent variable and the y-axis we have dependent variable. So air speed is independent, that's why it should be there on x-axis. And the current produced is depending on what is the wind speed or air speed, so that is on the y-axis. This is normally when we plot a graph, the dependent variables are on x-axis and the independent variable are on y-axis. So here the speed of the air or wind speed, which is meter per second, and the current will be there in ampere. But we don't have to sketch any shape here. We don't have to predict what will be the shape of the graph. We just have to plot a graph between airspeed on x-axis and current on y-axis and see the trend. Because maybe if they are directly proportional to each other, it is obvious they are directly proportional, because if fan speed is higher, turbine will rotate faster and produce more current. So if they are directly proportional, it will be a straight line. But if they are inversely proportional, then the graph between them will be a curve. But again, as I mentioned, we don't have to mention they are directly or indirect proportion. We just have to plot a graph between current and the speed and check the relation, whether if it is a straight line, it means they are directly proportional. If it's a curve, it means they are inversely proportional.
Mr. We will
So it's just based on the understanding of the topic and what you have studied throughout the course. So this planning of experiment is totally based on the topics. So next one, that is from May-June 2020 paper. A student investigate the effect of a color of surface on a metal container on a rate of heat loss or rate of loss of heat from the container. Like student is investigating how the color of the container can affect the rate of heat loss. She knows that black surfaces are better radiator of thermal energy than white surfaces, but she want to investigate the effect of other colors. So what she is having, the student is having, the following apparatus is available for a student. She's having a metal container with outer surface polished with different colors. She's having a thermometer, she's having a stopwatch and a supply of hot water. So simply what she will do, she will take containers which are having a different colors.
and Mr. She will add the supply of hot water
yeah,
and
equal
put
amount
the
of hot.
thermometer.
Yeah, that's right. Good.
Yes,
So she will take equal amount of hot water in 4 different
yes,
containers. Then she will place a
and put
thermometer.
the thermometer.
So she will place a thermometer in each container. And how she will start the timer or a stopwatch, for example, 3 minutes. And she will record the temperature for every 30-second interval. You can do for 5
So,
minutes.
Mr.
Yeah.
She will see the first water to be cold.
Yeah, the one which temperature decreases much faster than the other, or she can also, at the last, she can plot a graph between the temperature on y-axis and time on x-axis, because temperature, so she can plot a graph between temperature and time, and the one which is steeper or having a steeper slope, it means that is losing energy faster, because the one which is having a steeper slope, it means there is a greater change in temperature, or it will have a greater rate of cooling.
Mr. The independent on the x-axis, yes?
Independent, because time here is independent. When you start the timer, the time will continue. So time is independent. That's why time is on x-axis. Temperature depends on other factors. It depends on amount of liquid you took. It depends on size of the container, type of the container. That's why the temperature on y-axis. Now we'll answer
Yes,
according.
okay, sir.
Yeah, so draw a diagram of the apparatus used. So I already did, but whenever you draw a diagram, it should be labeled. I did not label any of them. You will mention thermometer, container, hot water. Then explain how you will carry out the investigation. How you will carry out the investigation, how you will identify which one is losing thermal energy faster than the other. So we will add, like example, you can mention take 10 cm cube of a hot water and transfer it into a container, then record its initial temperature and record the temperature after every 30 seconds for 3 minutes. And then repeat the experiment with different colors of container.
Container.
So we'll place or put 10 cm cube or add 10 cm cube of hot water. Then record the initial temperature by thermometer. Then we'll start the timer, the stopwatch. Then record temperature after 30 seconds. Then we'll repeat for 3 minutes. This is a procedure which we will follow, and then we'll repeat with different containers. Different colors container basically. So this is the answer for how we carry out. Then state key variable. So what are the things we should keep constant for the fair comparison?
Yes, Mr. It can be the thermometer.
Type of thermometer,
Yes.
but more
And also the quality of the container, it can be.
shape of a container, the type of a container as well. Like example, all are made up of say copper, because
Yes.
or all are made up of glass, but they have different colors. So type of a container, there are many things which can affect this. So type of a container, size of the container, room temperature or the lab temperature,
Also, Mr. the purity of water.
yeah, or amount of water, volume of the water,
Yes.
or
Mr. Purity is correct or
yeah, that's the same thing. Basically, when I mention, sorry,
Can you say that the water, like all of the water have the same temperature?
you mean the initial temperature?
Yes.
Yes, that's right. So, and it is not necessary that it should be 100 because they mention it is a hot water. So initial temperature can be 80 as well. Because they mention it is a hot water. So hot water 80, 70, 60 can also be referred as a hot water. So we can mention initial temperature of the water. So these the size of a container, the surface area of the container, volume of the water, many factors are there. Then draw table or tables. So whenever this type of question is there in which you're doing a rate of a cooling, so what table you can draw? You can have a temperature and time, and table should always be with a column heading. What is the meaning of a table with a column heading? It means like the unit of the physical quantity which you are measuring should also be mentioned. Like we are measuring a time, so time should be in second. And as I mentioned, we are measuring a time for every 30-second interval. So first it is 0. This I can complete because it's not necessary that I should complete, but I can complete according to the question. As I mentioned, I'm measuring for every 30 seconds till I will continue this 180. And the temperature, we are not doing experiment, so we cannot write any number here. So this is for container A. Then there will be a similar table is there for container B. Similar table is there for container C. So you can make for A, B, C container 1, 2, 3. 2 or tables are enough. Then how we will use our readings to reach a conclusion. Whenever we want to reach a conclusion in physics, the best way to reach or draw a conclusion is plotting a graph. So what we'll do, we'll plot a graph between temperature on y-axis
and the time.
Time on x-axis. And then what
We
we'll
must
do,
draw, sir.
no, you don't have to draw. But it is obvious that it is a hot water, so temperature will decrease. So it will be somewhat like this.
Yes.
Then how you will identify the rate of cooling, how you reach the conclusion. So we'll plot a graph that temperature on y-axis and time on x-axis, and we'll check the slope because slope represents the rate of the cooling. So the one which is having a steeper slope, it means that cool down faster, or that is having a faster rate of cooling. So this was a summer experiment related to finding the rate of a cooling, how it is affected by the surface color of a container.
Mr. This have 6 marks or 7?
Just a minute, I will see.
Yes, okay, Mr.
This is having 7 marks. The distribution of the mark, I can tell you, the distribution of the mark is when you mention, when you draw the diagram, include a thermometer, you will score 1 mark. Then when you mention about you will take a hot water, you will measure the initial temperature, you will measure the temperature for a certain interval, that will give you the 2nd mark, the procedure. And when you mention repeat the experiment with different containers, you will score the 3rd mark. And when you mention the variable which must be kept constant, the 2 variable, so that will be the 4th and the 5th mark. And the table with a column heading, that will give you 1 mark. And then how you reach a conclusion, the greatest temperature change or greatest change in a temperature or a drop in temperature shows that is the best radiator. Or you can plot a graph and check the slope. The one which is having a steeper slope, that will have a greater rate of cooling. This question is related, this experiment is related to electricity. A student investigates the resistance of different wires. So we have to plan an experiment to investigate the resistance of a wire made from different metals. So there are different metals. We want to investigate how the resistance of different wires changes. So investigate the resistance of different metals, and resistance can be calculated by using voltage divided by current. So what we'll do, we'll take a sample of a wire. We'll take a wire. To measure the voltage, we always connect a voltmeter, and voltmeter is always connected in parallel. To measure the current, we'll connect an ammeter. Then we'll have a supply, a switch will be there, and there should be a variable resistor. What is the advantage of having a variable resistor? So using a variable resistor, we can change voltage and current in the circuit. So we'll have different values, different sets of result, like we'll have some voltage value, different current value, and using a different voltage and current value, we can repeat the experiment for that wire. And whenever we want to find a resistance, for accuracy, voltage is on y-axis, if our current is on x-axis, so the slope represents resistance. But if we did opposite, if we plot current on y-axis, normally we draw current on y-axis, as I mentioned, because the variable, independent variable is on x-axis, so voltage is independent and current depend on voltage. So voltage on x-axis and current on y-axis, the slope of this line represent reciprocal of resistance. So it means like if 2 wires are there, say wire A and wire B, because the wire A is having a steeper slope, so A slope is more, it means its resistance is low. But for B, the slope is small, so it means its resistance is high. So whenever a current on y-axis and voltage on x-axis, the slope is always the reciprocal of resistance. So how we plan the experiment, this one, the first, write a list of suitable metal for the wires you will investigate. So normally what we can have, the metal wires, we can have a copper wire, common apparatus. So we can have a copper wire, we can have aluminum, because aluminum wires are also there. So you can mention common metals which we normally use. So iron, yes, iron can be mentioned. That's right. Iron can be mentioned. Steel you can mention. So here, like example, we have copper. Even you can mention an alloy as well. So brass, copper is there, iron is there, aluminum is there. Then draw a diagram suitable with a standard symbol. So that we did. Then explain how you carry out the experiment, how we'll do the experiment or how we carry out the experiment. So we'll connect a voltmeter in parallel and ammeter in series. We switch on the circuit and measure the voltage and current. And we'll repeat the experiment. So how we carry out the experiment, we'll measure voltage by voltmeter and the current by ammeter. And then we will change the voltage and current in the circuit. Then at the last, we will repeat the experiment because we want to find how different metals have different resistance. So we'll repeat experiment with different metals. Like first we did for say copper, then we changed the voltage and current for copper and we removed the copper. Then we did for iron and we changed voltage and current. Then we remove iron and repeat for aluminum and change voltage and current. Then explain that we did how we carry out the investigation. That is a procedure. State key variable that must be kept constant. What are the things we should keep constant for investigating how the resistance of a wire is changing? The temperature, the type of a voltmeter, ammeter, battery supply. Yes, you can mention that. That is also, but the best way start with the material. Like best way when you examine the material, because copper resistance changes with the length and area. So it is acceptable the type of a battery which you are using or the type of the meters. But the best thing we start with what we are investigating, because we are investigating the wire. So we should start any change in the wire. So the length of a wire, because if length changes, the resistance change. So length of a wire, cross-section area of the wire, the temperature of the wire, because if temperature changes, resistance also changes. So you can mention length or size of a wire or temperature of the wire. These parameters should be same. Then draw a table or tables to show how you display your result. So how we display our result, here they did not ask how we reach our conclusion, how we display our result. So we'll have three things, or you can have two or three, you can also mention. The first one, you're measuring a voltage. Why they normally say table or tables? Like example, we are doing for, first say this is for copper we are doing. Then there will be another table you will draw for iron. Similar table will be there. Only thing, the change will be iron. And the third will be aluminum. So we are measuring a voltage, the unit is volts. We are measuring a current, the unit is ampere. And we are measuring a resistance, so unit is ohm. So by changing the resistance of a wire, and same thing you will draw for iron as well as aluminum.